Okay, today I am going to be talking about horizontal motion and how it works. And on the whiteboard behind me, you can see me drawing what I'm going to be explaining as this video progresses. So, horizontal motion is when a ball or an object is launched off of a flat surface at a certain velocity. In this example, I am going to be launching the ball off of a 160 meter cliff, as you will see on the screen in a second, at a velocity of 20 meters a second. And our objective is to find the x, which is shown at the bottom, which is the water, and how far the ball will travel if it is launched at this speed from this height. As the ball is falling towards the water, it will maintain its velocity of 20 meters a second, as there will be no backwind pushing against it. As the ball is moving towards the right, the object will accelerate downwards, but it will not start with any vertical velocity. So now I am going to be plugging in the x's and y's that I currently have and the ones that I will need to find in order to solve the time it takes for the ball to hit the water and the distance it will travel in that time. So right now I am filling in what I know so far. So for the x, I know the initial velocity, which is 20 meters a second, and I'm trying to find the distance it will travel, so I'm putting a question mark next to that. As well as I have the delta y, which is 160 meters because that is the height of the cliff, and I need the acceleration of the y, which will be negative 9.8 meters a second squared, because that is the force at which gravity pushes you down. And I have the velocity initial for y, which will be 0 because there's no vertical velocity. As you can see, we have several points for the y, so we're going to use these points to solve the time it takes for the ball to hit the ground using the equation delta y equals the velocity initial of the y times time plus half times the acceleration of the y squared, which will be 160 equals 0 plus half times 9.8 times t squared, which I will have written on the screen. Now I'm going to solve it, and solved it would look like this. Time equals the square root of 160 times 2 divided by 9.8, which will give me the time it takes for the ball to hit the water. Now, since I have the time it takes for the ball to hit the water, I am going to use the same equation, but instead use the x, since I have enough variables for it. So the equation would be delta x equals velocity initial of the x times time plus 1/2 times the acceleration of the x times time squared, which will be written on the screen. Now that we have the equation written, we are going to plug in the numbers we have. So delta x equals 20 meters times 5.71. If we do it on the calculator, we will get delta x to equal 114.2 meters, which will be the distance it takes for the ball to hit the water.
Make the ground shake.